right, good folks. Okay, so today is the 22nd, Tuesday, 22nd. I just had my pencil and I misplaced it somewhere. Yes, baby. Oh, they left it on the desk. Also, I left it yesterday. Okay. Did you pick up the packet? Guys, you should be working on your warm up. Yes, baby. You're supposed to submit your notebook on your own time. All right, so let's do it. Okay, so first things first, it is Tuesday. We're going to go over the warm up. Today, I'm going to model for you. We're still doing factoring. We're going to factor difference of squares today. And remember, there is no homework. Please make sure that, however, that you study adding, subtracting, multiplying polynomials, and as well as factoring. Okay. GCF, grouping, factoring trinomial where A is equal to 1. Factoring a trinomial like we did yesterday where A is greater than 1. Please go back and look at those notes. I'll pause for the calls and give you time to get your warm-up completed. Okay, so it says the cost C of renting a bike and a helmet for H hours, so H represents the number of hours, is the formula given. And this is a linear function, okay? It's in slope-intercept form, which is y equals mx plus b. Only for y they use C, which is the total amount for renting a helmet and a bike. And H is the number of hours. So since this is H, the number of hours, which that's our X values, then this is our rate. So the rate that they're charging is $7.50 per hour, and you automatically have to pay the $3. Write an equivalent equation to solve for H. Okay, so you could write a next now equation if you wanted to. You could, yeah, let's write a next now. Starting at, what's the starting amount? I'm gonna write this. 3. The starting amount is 3. And then every single hour, what are you adding every hour? So it could be next is equal to now plus the $7.50 for every hour. You could write, this could be your equation that you write, okay? You can write the a sub n equation, either one, it doesn't matter. Or you can, yeah, well, that's good. All right, given this equation here, calculate the x-intercept and the y-intercept. Okay, so let's do x-intercept first. I'm going to abbreviate intercept. And then we're going to do the y-intercept. If we're looking for the x-intercept, that means we're looking for where the line crosses the x-axis. Any place that the line crosses the x-axis, your y coordinate is going to be 0. Y is going to be equal to 0. Okay? Any point where the line crosses the y-axis, your x is going to be equal to 0. So now in order to find the x-intercept, you're going to substitute 0 and solve for x. So here, your ordered pair, we know y is 0. Your ordered pair for your y-intercept, x is 0. Okay? All right, so let's solve for x first. We're going to rewrite the equation. We're going to substitute 0 in the place of y. -3 times 0, that's going to give me 0. This is gone here. X here is equal to a -6. So my x-intercept is -6. We're going to do the same thing for y. This time we're going to substitute 0 for x. I'm going to replace this with 0. And now I'm going to solve for y. So this is gone. I'm going to divide both sides by -3. -3 divided by -3 just gives me y. Y here is equal to a +2. Any questions, comments, or concerns? I'm going to pause to give you a chance to make corrections. Okay, so let's look at this one. They want us to divide here. It's supposed to be division. So let's divide the numbers first. Let's reduce this fraction. -3 over 9. -3 over 9 gives you what? Go ahead. Yes. Very good. Okay. So now we're going to subtract the exponents. If you don't see an exponent on these variables, automatically 1. So this is going to be m3 minus 1. This is going to be n 5 minus 2. So this is going to give me -1 over 3, m to the second power, n to the what power? Third. Okay, another way to write this is to just write -m to the second, n to the third, over 3. Did anybody get that right by themselves? No help? Nobody got that right? Oh, you did? Okay. A decimal is not wrong as long as you put 0.3 repeating.
Yeah.
But in these problems, especially with exponents, a lot of times you're not going to see the answer as a decimal. You'll see it written as a fraction. But it's not wrong.
Okay.
But just note that most of the time you'll see it as a fraction. All right. Kirsten, are you okay? Sit up, babe. All right. Put that away. Take out your interactive notebook, please. Yesterday, we worked on trinomials, factoring trinomials, where your A value is greater than 1. Ian, come up to seat number 13, please. It's right here in front. Sit right here. All right. So we did number 4. Okay, and I wanted you to complete 5 through 10. 5 through 10 on your own. I'm going to go over a couple just to make sure that you got the right answer. Okay? Yes, babe. Have one. It's online. Just get it offline. All right, here we go. Number 5. You have 2v to the second plus 11v plus 5. All right, so we are going to factor. First thing you always look for is GCF. There is not a GCF for this trinomial other than 1. So since this first number is greater than 1, it's not equal to 1, but it is greater than 1, What's our first step to factoring this problem? Does anybody remember from yesterday? We do draw the chart, that's true, but what do we do? Multiply the first and the last together. Very good, y'all. Very good, ladies. So when I multiply these two together, what does that give me? So we got a positive 10, okay? And the sum has to be what? A positive 11, the middle number, okay? So you multiply these first, and your sum is going to be the middle number. All right, so let's see. Let's see what two numbers can be multiplied together to give you 10, and when you add them, you get 11. Go ahead. Say again, baby. 10 and 1. 10 and 1. Okay, very good, babe. So when you add positive 10 to positive 1, you get a positive 11. Okay, so that's my first step. I've done that. What do I do next? What's the next thing that I need to do? Yes. Put the numbers from the chart that you got and put them in between. Very good. What am I putting them in the middle between what? 2b to the second power and 5. Very good. So make sure you bring these down. Very good. Bring the first and the last numbers down. And the two numbers that you found in the T-chart go in the middle. It doesn't matter which one you put first, but they both have to add up to the middle number, which is 11V. So that means I have to have a plus 10V, don't forget the variable, and a plus V, 1V or just V. Okay, any questions about that step? Close your laptop, baby. You don't need your laptop. Close your laptop. Do you understand this part? You sure? Okay. So now, what's the last step that I have to do? I have 4 terms here. What do I do after that? Somebody different. He's already given me all the answers. Tucker? Factor the 2 on the right and the 2 on the left together. Very good. What is that called? Factor by what? Greatest common factor. Grouping. Factor by grouping. But you are finding greatest common factor, okay? So that's good. So we're going to find the GCF of the first 2 terms. What's the GCF of the first two terms? Hatcher? What's the GCF of these two? Greatest common factor. 5 won't go into 2, so can't choose 5. That's okay, baby. Try again, please. 2. You can try 2 what? 2V. You can take out a 2V. And if you forget, draw a factor tree for both of these like we did in finding GCF, okay? All right, what can we multiply times the 2V to give me 2V squared? V. What can we multiply times 2V to give me a positive 10V? Positive 5. Any questions about how we factored the first 2 terms? So let's do the second 2. What's the GCF between these 2 terms? 1. So we got plus 1. Don't forget the plus. What can we multiply times 1 to give me V? V. What can we multiply times the 1 to give me a positive 5? 5. Positive 5. Okay. So now, what's the last thing that I do here? This is factor by grouping. What do I do last? Say again, babe. 2V plus 1 in parentheses. Very good. Times the V plus 5. Any questions about how we get these 2 binomials as our factors? Okay. Did anybody get that right on their own? Okay. That's good. Anybody still copying? All right. Let's do number 6, please. And at this point, we should be checking because I wanted you to do these on your own. We have 6, 2n to the second plus 5n plus 2. Again, we look for GCF for all 3 terms. The GCF here is 1. You don't have another GCF. So our very first step is going to be to multiply the first and the last together so that you can make your T-chart. Bless you, babe. When we multiply a positive 2 times a positive 2, what does that give us? That gives us 4. The sum of those factors have to add up to the middle number, which is what? Huh? 5, positive 5. What two numbers can be multiplied together to give me a positive 4? And when I add them together, it also gives me a 5. Yes. 4 and 1. Positive 1 times a positive 4. Okay? So we're using positive 1 and positive 4. Put your phone up. All right, so now we're going to bring down the two numbers on the end. 2n to the second plus 2. We're going to use these two numbers as the middle terms to break down the 5n. So we have 1n plus 4n. 4 plus n. The last step is to factor by grouping. Okay? So when you factor by grouping, you're going to factor these two together and then these two together. Any questions? Close your laptops, please. Close your laptop. All right. What's the GCF for these two terms right here? Angel? Greatest common factor. N. What can we multiply times n, Dalton, to give us 2n squared? N? 2n. Don't forget the 2, okay? What can we multiply times n to give me n? Yes, 1. Very good, baby. GCF of the second two terms? 2. Positive 2. What can we multiply times positive 2 to get 4n? 2n. What can we multiply times 2 to give us 2? Positive 1. Very good. Okay, so now what do we do here? Final step. Parentheses n plus 2. Very good. Okay. Any questions about that? All right. I want us to continue. We did through 10 yesterday. So let's do 11, 12, 13, and 14, please. I want you to go ahead and do those now. I'm going to pause here, and then we'll move on to factoring difference of squares. So I'm going to give us a couple minutes. If you don't finish that, then you just have to do it for homework. But you should have time to finish. I'm going to set my timer. Let's look at number 11. Number 11, 4n to the second minus 15n minus 25. Okay? All right, so GCF, there's no GCF for all three terms other than 1. So we're going to multiply the first and the last together. We're going to make our little T-chart. So this gives us a negative 100, and the middle number is 15. So the two factors have to add up to a negative 15. What two numbers can be multiplied to give you a negative 100, and when you add them, you get negative 15? What you get? Negative 20 times a positive 5. So when you add negative 20 plus 5, you do get a negative 15. Great job, babe. Okay, so now we're going to bring the first term down and the last one down with enough space to put two numbers in the middle. The two numbers we're going to use to break down the negative 15n is a negative 20. So that's negative 20n plus 5n. So now we can factor by grouping. What's the greatest common factor, GCF, between the first two terms? Say again. 5n. Good job. Oh, 4n. Sorry. I said 5. I'm sorry. 4n. When you take out a 4n, what can you multiply times 4n to give me 4n squared? We got n. What can we multiply times 4n to give me negative 20n? Negative 5. Okay. Now let's look at the second two terms. What's the GCF between the two? 5. So we got plus 5. What can we multiply? 5 times to get 5n? N. What can we multiply times positive 5 to get a negative 25? Negative 5. Okay. So now what we do? What do we do after that? Put 4n plus 5 together, and then n minus 1. And these are my two factors. If I were to multiply them together, I would get this trinomial as my answer. Okay? So let's do, any questions about that? All right. Okay. Yes, baby. Which paper was that from? Do you have that one? If you don't, I'll give you one. You know what? I gave you the wrong one. That's my fault. Sorry. Yes. Did I give you the wrong one too? All right. Okay, so let's try number 12. 4x squared, huh? I didn't hear you. I'm sorry. Minus 35x plus 49. That's right, right? Yes. Okay. All right, so GCF, all four. Let's see. No, it's not. 7, 4. No, these two 7, but this one's not. Okay, so let's keep going. So let's multiply the two together. We got 4 times 49. What's 4? What's 4 times 49? Oops, y'all. We got all these numbers. Okay. So we got 196. That's a perfect square. All right. So we got 196, and the sum has to be a negative 35, right? The middle number. So what two numbers can be multiplied together to give me the positive 196, but when you add them, you get 35? Okay, let's break down 196 so you can see it. Let me put it over here. 196. What two numbers can be multiplied together to give you 196? You can do 49 and 4. That'd be smart, wouldn't it? All right, break down the 4 to 2 and 2, and the 49 to what? 7 and 7. Okay. All right, and so what are you getting? What did you say? I didn't hear you. 27. All right, so we could do 28. Okay, and we can do 7. Okay, and both of them, they would have to be positive or negative. They both would have to be a negative in order to multiply, right? And get a positive. So what's a negative 28 plus a negative 7? Negative 35. All right, so now we got that. That checks out. We're going to bring down the first and the last. And we're breaking this number down in the middle to be a negative 35x. So we got minus 28x minus 7x. So now we can factor by grouping. What's the GCF of the first two? What can we take out? We can take out 4 what? 4x. What can we multiply times 4x to give us this 4x squared? We got x. What can we multiply times 4x to give us a negative 28x? Negative 7. Okay. All right, let's do this. What's the GCF between these two? 7. Positive or negative? I would take out a negative 7 so they can be alike. You see that? Because if you don't, this is going to be a negative x. So that's called thinking ahead. So let's take out a negative 7 so that when you multiply, what can you multiply times negative 7 to give me a negative 7x? Just the x, okay? Right? So far it's alike. What can I multiply times negative 7 to give me a positive 49? Negative 7. Negative times a negative is a positive. Now they are alike, okay? So now what do I do for my last step? Factor by grouping, what do I do now? Put 4x minus 7 in parentheses together. And beside it, I'm going to put what? X minus 7. If I were to multiply this, I would get this trinomial as my answer. Any questions about number 12? Okay. All right. Let's go. Let's do the next page, which is going to be page what? 2. This is factoring difference of squares. This one's easy. Go ahead. We only needed it for the warm up. All right, when you're factoring difference of squares, I'll show you this. You have n squared minus 81. What you notice is that both of these are perfect squares, okay? The square root of n squared is just n. And what's the square root of 81? 9. Okay, so this is how, when they're perfect squares, you have 2 parentheses. You're going to put n in each parenthesis because n times n will give me this n squared. And 9 times 9 is going to give me 81. So I have a 9 here and a 9 here. Because it's a negative, in order to get a negative 81 when you multiply, one has to be a negative and the other one has to be a positive. And this is your answer. That's it. Let's do another one just like it, okay? This is difference of squares. And it's called difference because we're subtracting. It's called squares because they're perfect square roots. Okay? So number 2. You got a squared, which is a perfect square, minus, that's difference, subtraction. 121 is a perfect square root. Very good. So you got 2 parentheses, a in each. A times a gives you the a squared. What's the square root of 121? So you got 11 in each. And in order to get a negative 121, one's got to be a negative, one's got to be a positive. You can put positive first and then negative. It doesn't matter. One's a negative, one's a positive. Any questions about how I did that? How you feel? You okay? 3. N squared plus 16. Those are both perfect squares. Okay, very good. So look, for this one, it's positive. It's not difference, but it is squares. So we got n in each. What's the square root of 16? Go ahead. 4. And they're both positive. Questions. So you can write it like this, or n plus 4 squared. Any questions? Number 4, 9 x squared minus 144. Again, both of these are perfect squares. What's the square root of 9? 3. What's the square root of x squared? X. What's the square root of 144? Very good. So plus 12 minus 12. Or you could put the minus first. Are y'all okay? Not too shabby, you think? This is probably the easier one, right? Okay. All right, 2. Okay. 2 is not a perfect square. Sorry, you couldn't see that. 2 is not a perfect square. Is there a GCF for this? Greatest common factor for either one? It's not, okay? This one is prime. Can I factor that, okay? Number 6, 4w squared minus 9. These are both perfect squares. You got 2 parentheses. What are you going to put in the first parentheses? 2w, you said minus what? 3. What about the second? Plus 3. All right, so I want you to do 7, 8, 9, and 10, okay? That's it. Please put your calculators back. I'm going to stop the video here.